Hi, I'm Ms Hearn. Let's get started. We're going to talk about how to use known relationships to find the measures of angles. We're given a diagram with a pair of parallel lines marked L1 and L2. There are two transversals slicing through these parallel lines, the transversal L3 and the transversal L4. This has the effect of forming a triangle and a total of 14 angles. We're given that two of the angles inside the triangle are 66 degrees and 57 degrees, and we have to find the remaining 12 angles. We're going to do this by using what we know about certain angle relationships. For example, when a pair of parallel lines are crossed by a transversal, the two angles on the same side of the transversal and the same side of the parallel lines are called corresponding angles. On the other hand, when two parallel lines are crossed by a transversal and we look at the angles that are between the two parallel lines but on alternate sides of the transversal, we call these alternate interior angles. And if we look at the angles that are outside the parallel lines and on alternate sides of the transversal, we call these alternate exterior angles. Corresponding angles are equal, alternate interior angles are equal, and alternate exterior angles are equal. Vertical angles that form when two lines are crossed and the angles are directly across from each other are also equal. When a ray projects off of a straight line forming two angles, those angles are necessarily supplementary or add up to 180. When a right angle is broken into two pieces, those angles that are formed are called complementary angles, and of course they must add up to 90 degrees. If you add up all the angles on the interior of a triangle, they will always sum to 180 degrees. And if you have a triangle and one of the sides is extended outward, this exterior angle will always add up to the sum of the two opposite interior angles. We'll find in this exercise that these relationships are more than enough to help us identify the measures of all 12 of the missing angles. I always like to start by identifying all the vertical angles. So for example, angle 2 is directly opposite angle 57. They're equal to each other. So I'm going to mark angle 2 as 57 degrees. Similarly, angle 9 is vertical to this angle marked 66 degrees. So I'm going to mark that one as well. Anytime I have vertical angles pop up, I like to mark those. Now, notice that we have a triangle. We know that the angles of the triangle must add up to 180 degrees. If we know that two of the angles are 57 degrees and 66 degrees, we can subtract to find the third. The sum of 57 degrees and 66 degrees is 123 degrees, and the difference between 180 degrees and 123 degrees is 57 degrees. This means that angle 7 must be 57 degrees. It also means that by vertical angles, angle 12 must also be 57 degrees. Also notice that angles 9 and 10 are supplementary. They add up to 180 degrees. Subtracting 180 minus 66 degrees, the measure of angle 9, we see that angle 10 must be 114 degrees. And similarly, angle 7 and angle 8 are also supplementary. Subtracting 180 minus 57 degrees, we have that angle 8 must be 123 degrees. Notice that now we have a couple more sets of vertical angles. Angle 8 is a vertical angle for angle 11. So let's go ahead and fill in that angle 11 is equal to 123 degrees, just like angle 8. And angle 6 is the same as angle 10 by vertical angles, 114 degrees. Now let's turn our attention to the relationship between angle 6 and the combination of angle 1 with angle 2. I've highlighted these in yellow because you'll notice that they fit the description of corresponding angles. They're on the same side of the green transversal L3, and they're both on top of the parallel lines. This means that angle 6 is equal to the sum of angles 1 and 2. But angle 6 is 114 degrees, and angle 2 we know is 57 degrees. So if we subtract these two values, we can find angle 1. Angle 1 must be 57 degrees, just like angle 2. Now notice that automatically gives us another vertical angle. Angle 5 must also be 57 degrees. Now let's turn our attention to angles 9 and 4, which also are corresponding angles. That means that they're equal. So we know that angle 4 is 66 degrees. Now once we know angle 4 is a vertical angle directly across from angle 3. So they must be equal. So angle 3 must be 66 degrees as well. So we have found all of the angles numbered 1 through 12 on the diagram. I hope this video was helpful to you. If it was, please remember to like it. You can subscribe to Ms Hearn Mathematics on YouTube, visit my Facebook page, or follow me on Twitter at Ms Hearn Math.